You can get a sense of why this thing's inverted here. Cool. All right. Everyone, product rule, I don't think you'll see its value with the polynomials. All right? So when I work with you on product rule, let's use e to the x, okay? Let's use e to the x. I don't think you'll see the value of product rule unless you use something like e to the x or ln of x. Sound good? That's why I just showed you both of those. If you're like, why are you showing us ln of x now? The textbook waited till later. You won't see the value, the need, the necessity of a product rule without it. For instance, here. Now would you agree that's a product of two functions? We'll find my product. But watch this. Watch how so many people in this class are like, I'm product rule. They're like, who cares about product rule? I don't need it. Because they know a way to avoid product rule here. A lot of you. How could you avoid product rule?
Multiply them.
You'd expand it. It's not hard to FOIL. I think it's faster, actually. I'll be honest. I wouldn't use product rule here. You're like, let me just FOIL this thing. 1x squared plus 3x plus 2x plus what, 6?
6, yep.
So what's its derivative? 2x
Plus 5.
plus 5. Here, let me move that closer here. Ta-da! Did I need product rule?
Nope.
No. So you don't see the value of this with the, you don't see the value. I'll just expand it. I'll do it every time. Even with 3 of them, it doesn't take that long. So, but we're going to do product rule now to make sure we get the same answer. Okay? So what is product rule? It deals with, you got two functions. And I think for another set one, you can use letters M and N or F and G. All right? Is it okay if I use M and N?
Okay.
All right, I'll call this one M, and I'll call this one N. Product rule says this. If you have y equal to like an M times an N, product rule is you do M times N prime plus N times N prime. That's the product rule. Not too hard to remember either. Here's a phrase. First times derivative of the second plus the second times derivative of the first. If you like phrases to remember. Product rule. It's the first times derivative of the second plus the second times derivative of the first. Right? Why use letters M and N? So it would be N times N prime plus N times N prime.
So like if you have y equals to x square ex, so it will be like x square ex plus ex plus 2.
That's it. And that's when you see the value of product rule. We'll do some on the board. When you get you need it. Like there's no other option. It deals when you have like something like he said, something in front of an ex. Oh, I'm sorry, you can't do power rule with this, right? You have to use product rule. We'll do that in a second. I just thought before we do, Evan, would you try product rule on this, and what should we get for our answer? We'll get what?
Same, 2x plus
Yep,
5.
so let's remember, 2x plus 5 is going to be the answer, right?
Mm-hmm.
All right, let's do product. So I'm going to do, we'll look, by product rule, m times n prime plus n times m prime. If you don't like m and n, you can use f and g. F times g prime plus g times f prime, right? I didn't use f because I'm worried everyone thinks f is y. So I chose letters m and n. All right, what's m?
X plus 2.
What's the derivative of n?
1.
And so far so good?
Mm-hmm.
Derivative of n is just 1? That sometimes gets people. Are you sure you're okay? Okay, that's what I figured. If that throws people off, they're like, what? Because we did power rule in this thing. Derivative of n, what's that power right there? 1. 1 times a 1 is a 1, and x to the 0 came to 1, and then what was derivative of plus 3? Plus 0. So every time you look, derivative of x plus 8, 1. Derivative of x plus 12, 1, because that's what's going to happen. Good, now what's n?
X plus 3.
And what's n prime?
1.
Did we get the same answer?
Yep.
Add like terms, distributive property. To me, this took longer than the other one. So I just want to point out, you don't really see a value to this until you deal with the exponentials like e dx. Right? Good to go? So we got in our next problem. Let's go to something with e to the x, right? And then afterwards, maybe we'll do a slope, find the equation of the tangent line, drawn at the curve at some value. All right. Can I erase?
Mm-hmm.
Wow. All right, I'm going to use the one you chose. I like this. Everyone letter A? Could you differentiate? No question about it. You are forced to use product rule. Now, do you remember I did 5e dx? I didn't need product rule because there was a constant in front. Do you all see the difference? The derivative of 5e dx was 5e dx. You don't need product rule. It's constant in front. But if there's an x squared in front of the ex, that's x squared times e dx, that's a function times a function, you must use the product rule. So give it a shot. Get your m, do your n, do your m prime stuff, right? First times derivative of the second plus second times derivative of the first. Okay, your m, your n. M times n prime plus n times n prime. So m is x squared. What's derivative of dx?
Ex.
That cool, everyone?
Mm-hmm.
The only function whose derivative is itself, right? I should put a constant in front of it. Plus e dx. And what's n prime?
2x, sorry.
This is 2x, right?
Mm-hmm.
Everyone okay with that? Okay on each derivative? Wait, go ahead. Which one was that?
Where did you get the 2x?
Oh, so you're good, you're good, you're good, and it's like, wait a minute. M prime. So here's my m. I need to derive that. I'm doing power rule.
Oh.
So 2 in front, and then decrease it by 1.
Yeah.
Now, a lot of students leave the answer like that. The first thing is, when you leave final answers, we should never leave this 2 in the middle. You can always think of it as a coefficient. So where should that 2 go? Right there. So what's a good way to write this? X squared e dx plus 2, and then I like to put x's before e dx. It keeps you organized. It keeps you organized. Coefficient in front, then any monomial like x squared or x cubed or x to the fourth, and then I'll add e dx at the end because it helps you with factoring.
Would you also want us to factor it out?
Great question. You wouldn't have to, but this is a great question. There's going to be a need for that in chapter 4, so we might as well do it now. But if the problem said just find y prime, this is a great way to write the answer. They said differentiate, I'm done. But there's going to be a need to factor these in the next chapter after our next test, for test 3. And then I'll get your questions. So real quick, what could you factor out?
E to the power x.
You can take out an x. You can factor out a
X.
e dx. And what are you left with?
X plus 2.
X left over, a plus is left over, and a 2. Cool. All right. Hey, question.
Yeah, you got 2x, why, and then you got x squared on the right. Why isn't that 2x also?
Oh, look, because this was, remember, here's the formula. M times n prime plus n times m prime. So this was just m. You go, what does that mean? I just write the exact expression I see there. But this was m prime, that means the derivative of m. So you had to take the derivative of that portion. If you don't like letters m and n, some students like f and g. If you want to do that. But when you're doing this part, you're just talking about what's my f, right? And when you're doing that part right there, you're doing what's my g. And the other ones are the derivatives. Cool. All right. Hey, when I did a letter A, because here's letter B. use x equals 0. Find the equation of tangent line at x equal to 0. I thought we'd get a cool number, everyone. What happens when you put a 0 in there? It makes the whole thing turn into a what?
0.
0. I could do 1.
Mm-hmm.
The answer's gonna look funny though. Is everyone okay with a funny looking answer? All right. Find the equation of the tangent line drawn to the curve where? I was gonna use 0, but I don't think you'd get appreciated so much because it would just make this whole thing 0. The slope would be 0, right? So how about at x equal to 1? Although I think a part of this answer may look weird because everyone, what's e to the 1 power? Just the letter what?
E.
So it looks like we're gonna have to have an e in our slope. Looks like one of our y values is gonna have to have an e in it. I know. Well, first of all, what's the point? It's kind of like this thing, right?
Yeah.
Well, let me write the xy coordinate. At x it's 1. I'll plug a 1 in there. 1 squared times e to the 1 is
E.
There's your x1, there's your y1. Y minus loss of 1 equals m, derivative. There's my e. There's my 1. On the board, somewhere is the slope. And where's the slope?
X.
It's right there, the y prime, right?
Mm-hmm.
Y prime is slope, right? That's this. It's the y, derivative. But what do we gotta plug in here?
1.
I will just drop a line. X equals 1. Now what does this math turn into? 1 times e to the 1 times 1 plus 2. So what is that slope?
3.
1 times e times 1 plus 2, 1 times e times 3, 3e. That'll be my slope. 3e. Done. Looks weird though, huh? I know. Better than getting a slope of 0 though. We get a slope of 0, you would just have y minus, the value of whatever the y point was equals 0. Quotient rule. When do you need quotient rule?
When the 2.
Number 14 will be good enough. Heck, number 15 will be good enough. 13 will be good enough. I try to do the evens so you can do the odds. I like 13 more than 14, so we're gonna do 13. And when this is in 3.2, and it's number 13, the directions differentiate. What equals x squared, no, x cubed over 1 minus I squared. So this is brand new now. This is brand new. We need a rule. What rules do we know so far? We know the power rule. It's awesome.
Product rule.
Then you got product rule. Okay, that's good for like x squared times e to the x, right? But if it was x plus 2 times x plus 3, we could just expand something and use power rule. Well, now we need quotient rule. Well, we did a fraction back in section 3.1, but the denominator was only solo, right?
Mm-hmm.
This is called a binomial. We have a binomial in the denominator. Even if you try to factor it, it wouldn't help. Cool? So we're going to use what's called a quotient rule. So this was what rule?
Product.
Now this is product rule. How about quotient rule? Everybody, you okay if I use M and N?
Yeah.
All right, use M and N. Why don't I use F and G? The book likes to use F and G, or people have taught F and G. I'm worried students think F is Y all the time. So I don't want you to get confused. So if Y equaled this M over N, the quotient rule says N, you start with the low part, times M prime, and we check this out. That's a plus. This is a
Minus.
minus. M times M prime minus M times M prime all over N squared. I'm gonna leave this on the board all class. That's an important rule.
Did you ever do this low D high minus high D low over low low?
Yeah, I think it's a good way to remember it. And those of you who had calculus before probably know that expression that Art just said, that phrase. You know, sometimes you get these things, they start getting a little bit more in depth, and you don't want to mess it up every time you do it. Could you imagine how I could do this backwards easily? And it happens that when I'm grading, I'm like, the student did M times N prime minus this, and they get the same answer but negative. So there's a good phrase here. Let's put it down. And let's call this the high. Are you okay if I misspell high? High is S-H-I-G-H. Can I just call it H-I?
Yep.
And how about low, L-O-W? You okay if I just call that L-O? High over low, right? Well, this expression here is